All right, so starting up kmyth again, I deleted the NV chip. So when we do sudo tpm server, it will create a new one, and everything is basically like it's brand new. There's nothing inside of the TPM. The PCR values are all 0. They would have been anyway if you do a reset, but I'm just going to go ahead and log into the TSS user. And so I'm kind of continuing off from the last video. Here's where we have the create policy digest. What I've done here is add in a PCR read. So in order to do that, we have to have all these extra variables. This is going to be the PCR selection being read in, which is just the PCR list that we have been using this whole time. This is going to be the update counter, which is a value that gets updated by the TPM itself. So it's just an integer, and we don't actually give it a value or anything. This is the PCR out selection, but it should just be the same thing as this after it gets updated by the TPM. It's going to be that same bit mask where we have, 1, 1, 1 for the 0, 1, and 2, and then a bunch of zeros before that. That's just to specify, which PCR index values we're going to be reading from. Then we also have PCR values, which is just going to hold all of the values that get read in from the TPM. And this I probably could have called later. It's the same thing as this, but I'm going to be doing 2 different PCR reads. So later on, after I do the extend, I'm going to do a PCR read down here. So this is going to be the PCR read before we do any type of extension. So if I drop a breakpoint here, run the debugger, if I come down to the PCR values, you can see that we have a count of 3, and that's based on our selection that we gave it, and that's based on the selection that we gave it in the PCR selection in from the PCR list. And then if we look at the digest, you can see that 0, 1, and 2, they all have a size associated with them. And if you look at any of the others, 3, 4, they all have a size of 0. So basically the TPM is only updating the indices for the ones that we are telling it to read. Now if you actually look in the buffer, it's literally all zeros, which we probably would expect because this is the first time that we're reading from the PCRs. And if you, look at the TPM2 tools, when we read from the PCRs, they start out all 0. So I'm going to go ahead and stop there and remove that breakpoint. And then coming further down, this is still a bunch of code that we had before. This is just creating the policy 1. The same thing that we've done in the past. I haven't modified any of that code. Then down here, this is where we're going to be doing the PCR extend. So I just created a hex value. This is actually the same one from the other video. I was really kind of hoping that when I did the extend, I could get the same deterministic value out. And I think it's highly possible that somewhere in the TPM tools implementation, they did something different than how we're doing it here. And even one really small change to the calculation will change the output entirely. So this is just, again, just a random SHA-256 digest. There's nothing about it that is special, but we just created a hex array here, and we're storing all of these values inside of this hex array. So if I drop a breakpoint here, run the debugger, and if I look in the hex and look at the memory view, you can see that we just have all these hex values one after another. And this is the same SHA-256 digest that we came up with earlier. So moving down, not entirely sure what all this code does. For this, I was referencing the TPM2 TSS in here. They have some call to PCR extend. Granted, the way that they implement it is different than the way that we're implementing it. But I tried to be, a little bit consistent with what they were doing. But all I did was copy and paste this right here because I think for an extend, it has to have an actual auth command. It cannot have a null command. And so all of these different variables that we have inside of here could potentially alter the output of the PCRs once we do that hashing. So there's a lot of reasons why this could be a little bit different as an output than what I got from running the TPM2 tools version. Continuing to move down, this is digest values. So looking back at the TPM2 tools implementation, when we did the PCR extend, we're saying SHA-256 is equal to, and then we pass in a hexadecimal string. So that is essentially what we're doing here. That SHA-256 is being represented by the kmyth hash algorithm. And then that hexadecimal value that we're passing in, which is this hex right here, we're doing a mem copy where we take in that hex value and we're copying it into memory inside of digest values, digest 0, digest dot SHA-256. And of course, we could, easily do a loop for this. I was just kind of lazy. We're just going through each one of these PCR values that we selected, again, being 0, 1, and 2. We're updating the value for the hash algorithm, and we're sticking that hex value, which is up here inside of the memory for this particular location. So again, if I drop a breakpoint, and if I come down to digest values, we have the count of 3. And then if I go to 0, digest, and then SHA-256, I can right click and view in memory. And we have B5, BB, 90, 80, etc. And again, that's just going to be that hex value that we have right here. So hopefully that should be working fine. So these are both variables that are necessary in order to do a PCR extend. This is going to be the output where the values get written later when I do the PCR read. I can move this down. So all we need here is the digest values. We update the values of those digest values. And then here we do the PCR extend, again, passing in the context. Here we're passing in the actual number for the PCR that we're updating. So again, we would implement all of this in a loop. But here we're just updating PCR 0, 1, and 2 using that hex value and that hash algorithm. And then we're passing in the session data, which is this auth command that we have here. And then we're passing in a 0 for the response, which I think is equivalent to a null response auth. And then, of course, we're passing in these hex values with their associated algorithm. So it should be doing an extend. And now I created a new TPML digest for the PCR values after the extend. And then we're calling another PCR read. We could declare new variables for PCR selection in and the update counter, but I kept all those the same. The only thing different from this one and the other PCR read that we did is that instead of this PCR values variable, I'm using a new one called PCR values after update. But these are all the same variables I'm using in both of them. So let me come down here, drop another breakpoint. So this is right before we start creating the policy to digest and doing the apply policy. So just to double check, PCR values, the original one that I read in, all those values are still going to be all zeros, and that is for every index value. Take my word for it on the second one. And then if we go down to PCR values after extend, again, we have the count 3. If we go to 0, check the buffer, now we have a new value. So if I look at the memory view, this is the new value that we have, 47, 59, 3F, blah, blah, blah. And for good measure, I have just kind of saved that in this notepad file, just so we know that is the output that we would expect, 47, 59, 3F, etc. And again, I updated 1 and 2 as well, so if we look at the buffer for those are also the same, 47, 59, 3F, 52. And we would expect them all to be the same because we gave them all the same hex value as an input. If, one of them was slightly different, even by one number, then the entire thing would be different. And that's about the only difference in the code here. It does a PCR read, then after it creates the first policy, it does a PCR extend, and then it does a PCR read again. Of course, in the actual context of kmyth, we would never do this. We would never do a PCR read. But for the sake of, proving to ourselves that this entire program works the way that it should be working, this is probably the most convenient method of doing it. So now that that's all done, I haven't actually run the program in entirety yet, so I don't have anything in this folder. So if I actually run the seal, and actually because I did execute that PCR extend value, I want to start over. So I'm going to delete that NV chip one more time because I don't want any values other than the ones that you saw to be inside of the PCRs. And if I did a PCR extend and then ran the program again, even though I only ran it in the debugger, I think it still modifies the values of the PCRs. And then I could do a PCR reset, but I would have to write that into the C code, and it would be easier to just delete the chip and start over. So running the server again, doing the login, and then I'm going to run the seal and run that in entirety. By ls, you can see I have the idk.ski, the policies.data that we talked about in the last video. And if I go to the desktop, all we have is that idk file that we did the seal on. So now the next step would be to go to the unseal, and coming down to this part where we call kmyth unseal. This is the name of the function inside of kmyth. And because, we're going to be referencing ski.pcrlist, I had to write this PCR read below the part where we actually parse the ski bytes from the file. So I can drop a breakpoint here, just to review, again, we have a PCR selection in. That's going to be the ski.pcr list, which gets read in from that file, the idk.ski file that we generated when we did the seal. And let me put this on unseal before I forget. And then here, we're just creating a new PCR update counter. Again, this is going to be updated by the TPM, so we don't actually do anything with it. This is just something we get as a response. And the PCR selection, again, is going to be another thing that we get as a response. And the PCR values, one more time, is a thing that we get as a response from the TPM, but it's going to have the values of those PCRs. So now we're calling PCR read. So I'm passing in a 0, but we should also be able to, do something like this where we have null command and response auths and pass in null. I'm not 100% sure about that, but again, I was looking at the implementation that they have here at the TSS, and they have TSS2 PCR read passing in a 0 and a 0. But I believe they're the same thing as having a null command and response auth. Anyhow, if I drop a breakpoint here, run the debugger, and if I come down to PCR values where we got our response from the TPM, we can see that we have 0, 1, and 2, and they should all be the same thing that we had before. So this is what I copied earlier. We have 47, 59, 3F, 52, and etc. So that means that the values of the PCRs are still the same as they were after we did the extend, which makes sense because we haven't done anything with them. So let me just go ahead and stop that, and then I'll run the program in entirety. No problems. And if we go to the desktop, we have the output. So that does confirm that for the second value of PCRs, before we do any type of PCR reset, that we do in fact have a successful unseal. And then doing another extend shouldn't be that hard. I could probably just copy and paste all this code right here. And I'll go ahead and drop it right underneath here. And I'm going to go ahead and remove that output file. Clear. So that file that we sealed should already still be sealed. I'm not going to run the seal again because that would update the value of the PCR registers. And on the second PCR read, this is actually called after extend. So here we're doing a PCR read. We're again declaring this hex value. And we can use any hex value we want here. This is easy because all I had to do was copy and paste it. Again, creating that command auth. These digest values, everything is still exactly the same. We're doing an extension on the PCR 0, 1, and 2. And this will be the PCR values after the extend. Then it'll try to unseal and it should fail. So before I actually do the extend, let me just run this one more time using the debugger and confirm that PCR values are still what we expect them to be inside of the buffer. And that is this value 47, 593F, etc. So that looks okay. So moving on, I'm going to run the entire thing, try to do the unseal. And it says the policy check failed, which is a good thing. Now the only thing we have left to do is a PCR reset. And honestly, the easiest way to do this probably wouldn't even be to do a reset. If I literally just remove that output file, cd kmyth bin. I still have that idk.ski file. It's the same file. It has the policy written onto it that it only unseals if I have the PCR values we just saw prior to the second extend, or if it's all 0. So what I could do is just close this whole thing. I wouldn't even have to delete the chip because all that information is saved on there. But if I start up the TPM again, it should default to all 0s in the PCR values. And we'll double check to make sure that that is correct. So now if I come to TSS2 PCR read, drop a breakpoint here, run the debugger. Inside of PCR values, I have these digest. They're all 0 for 0, 1, and 2. And so I'm going to go ahead and actually run the entire program, hoping that it will work. And we have it. So I think we can feel pretty confident that this actually works. All right, so the next step. I would think that the ideal behavior of kmyth would be if we have this, value that we expect to be the value of the hash after we update the PCR. I would think that we would have, a hash value like this. And in this case, we know that this is the result when we have a PCR extend using all 0s and then extend that with this value here. So I would imagine that we would want to be able to just type this value in as an argument and then convert that into hex. And then when we create our policy 2, right here, instead of a normal apply policy, the one that we have been doing, we would pass it in that value, and then instead of passing in an empty digest, we would say that this is equal to that hex value expected. And obviously this is not compilable code. I'm just kind of explaining the general thought process here. And instead of passing an empty digest size 0, we should hopefully be able to pass it that hex value, and it will write that into the policy somewhere. If we can make that function, then the only thing left to do would be make this prettier, cut out like any non-ideal programming practices. Like obviously down here, I'm just, repeating a lot of code. We can easily do this in a for loop along with this stuff right here and other things. But as far as the general functionality of everything, it appears to be working. And then once we get that all cleaned up, we can try to take this and convert it and put it into kmyth. Although in kmyth, they're also probably going to want an optional parameter where if the user is not passing in, this extra hash value, then they would only use one policy, PCR, the way that they currently have it set up. So all the details there are a little fuzzy. Like if we're doing a policy OR, do we want to use a regular policy PCR with the current values and then this expected future value? Or do we want to have two of these, future expected values? Obviously, these are the same thing, but imagine that they weren't. Like if we expected that, this was some other, value that we thought it might be. These are some other things to think about and consider moving forward. But as for now, that's about it.